Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we're going to solve linear systems by the addition method. So, with the addition method, number one, you want to write both equations in the form ax plus by equals c. If needed, you need to multiply one or even both of the equations by a constant so that the sum of one of the terms with one of the variables on the left-hand side is 0. Then you want to add the two equations together. So when you add the two equations together, you should have an equation in one variable that you should solve. Then you're going to use back substitutions to solve for the other variable. And then you can check your solution. Again, checking your solution is not necessary, but if you are not confident in your algebra, you need to check your solution. So let's start off by looking at 3x plus 2y equals 14 and 3x minus 2y equals 10. So this system is already written where the equations are the form ax plus by equals c. And it's already set up such that when I add these equations together, one of the variables go away. So here, I don't have to multiply an equation by a constant. So let's solve. If I divide by 6, x is going to equal 4. Then I need to go to one of my original equations to find y. 3 times 4 plus 2y equals 14. So I have 12 plus 2y equals 14. If I subtract 12 from both sides, 2y is 2 or y is 1. So my solution set contains the point 4, 1. Let's look at another one. 2x plus 3y equals negative 16 and 5x minus 10y equals 30. Well, this is not set up in a way that when we add both equations together, one of the variables drop out. But that's okay. We can multiply one or both of the equations by a number so that happens. So here, we're going to choose to eliminate the x. So when I want to eliminate the x, I have a 2 and a 5. And I think about the least common multiple of 2 and 5, and that's 10. So I need to make one of them 10 and one of them negative 10. If I multiply the first equation by negative 5, I'll get negative 10x minus 15y equals 80. So to get a positive 10 in the second equation for the x, I need to multiply by 2. I'll have 10x minus 20y equals 60. Now when I go to add, negative 10x plus 10x is 0. I have negative 35y equals 140. And if I divide, y is going to be negative 4. So now I need to find x. And I'm going to use my first equation to find x. 2x plus 3 times negative 4 equals negative 16. So 2x minus 12 equals negative 16. If I add 12, 2x is going to be negative 4. So x is going to be negative 2. So my solution set contains the point negative 2, negative 4. Let's look at another one. We have 6x plus 2y equals 7 and 3x plus y equals 2. Well, again, here if we go to add both of these equations together, neither one of our variables go away. But if I look at my y's, if the y term in the second equation was negative 2y, then they would. So let me multiply my second equation by negative 2. So my first equation stays the same. My second equation, when I multiply by negative 2, becomes negative 6x minus 2y equals negative 4. When I add this together, my x's go away and my y's go away. I have 0 equals 3. And that's a false statement. If you go back to the lecture where we solved by substitution and we were in this situation, we said, hey, we have a set of parallel lines, which means no solution, or the empty set. Let's look at another one. Suppose we have x plus 3y equals 2 and 3x plus 9y equals 6. Well, let's choose to eliminate x. I need a negative 3x here, so let me multiply by negative 3. I have negative 3x minus 9y equals negative 6. My second equation stays the same. When I add, I get 0 equals 0, which is a true statement. So my lines coincide, and my solution set, again, we had the same situation in the lecture solving by substitution. It is a set of all points x comma y such that, then you pick either one you want to. X plus 3y equals 2. Infinitely many solutions here. So remember that Dr. LV is always in. Please come back for more math help.